just studied an inverse. Number 3, these two functions are inverses. How could I tell they were inverses? Well, you see how the end result came out to be x on both of them? When I did f of g and g of f, when I do that, it becomes an inverse because it comes out exactly to x. We'll get to those later. But that as an example. So here's a function or a relation. Has some numbers, 1.2, 1.4, 1. Whatever, blah. Okay? And it has some outputs, inputs and outputs. Okay? So it's a relation because not all relations are functions. Are all functions relations? Yes. Okay? So we want to talk about it because everything has an inverse. But is that inverse a function? That's what we're going to kind of talk about today. Okay? So, an inverse is if you have your inputs and your outputs, notice your outputs become your inputs, the inputs become the outputs. Is that too hard? That's the definition. Inverse is when your inputs become your outputs become your inputs. That's the definition of our inverse. Okay? So for example, if I had this relation, x is 0, 1, 2, and 3, y is negative 5 that corresponds with the 0, negative 4 with the 1, 2 with the negative 3, 3 with the negative 3. Is this relation a function? Does anybody remember what the definition of function meant? Vertical line, if you recall. Like, for example, a parabola. If I drew a vertical line, it would pass, correct? But notice if I did a sideways parabola, would that pass? I don't know if they called it the pencil test. In the past, we call that's called the that's the continuous. No, we've talked about that kind of a way. The continuousness. Remember that's discontinuity. If I can pick up my pencil, that's discontinuity. But the vertical line test. If I can draw one straight line, that represents one input. If I only cross the graph once, that represents one output. Because the definition of function is every input has one and only one output. Okay, so notice this represents one input. How many outputs did I have? 2. So is this a function this way? No. Is this a function? Yes. So is this 0, negative? Never mind. I'll do that. Okay, so here is the relation. What graphs? What are the graphs of t and inverse? Okay, so let's graph them. That's what they're asking us to do here. This is different than the lesson. We'll just go 3. 0, 5, 1, 2, 3, 4, 5. 1, negative. Oh, well, that's now a positive. 1, 2, 1, 2, 3, 4.
Yeah, now the whole graph is getting
It's just a relation. A relation's not a graph. It's a bunch of points. So I have 2, negative 3, negative 4. Shit. That's negative 4. Sometimes it's a Friday. It's a Friday, people. It's a Friday. Anyway, what would be its inverse? 5, 0, right? 1, 2, 3, 4, 5. The red dots would be the inverse relation, right? Negative 4, 1. 1, 2, 3, 4, 1. 2, negative 2, so it'd be negative 2, negative 2, negative 3. Is the inverse a function? Because of the negative 2, 2, and the negative 2, 3, it would not be a function. Okay? Sure, whatever it is. Just shut up. Jimmy, you get the idea. Yes, sir. Yeah, we just did rational functions, input. And it had a hole in it. Yes. Not all functions are continuous, I think that's what it is. I just switched the X's and Y's. And just for Jimmy. Okay. And notice that vertical line here makes it not pass, right? Everybody see that? Pretty simple, right? Okay, so let's go on to this one. A function for every element of the range of the function corresponds to exactly one element of the range. Okay, so one-to-one. Let me show you a picture of one-to-one and see if you guys can understand. Okay, here's one-to-one. Is that guy one-to-one? No. Is he a function? Yes. Not all functions are one-to-one. The definition of this is meaning every x, this is kind of, some of you guys are confused by that sentence. I'm confused by that sentence. Okay, basically what one-to-one means is that every x has his very own y. Because notice here, that's why this is not a function. Because 3, let's say this is at 3, 0, and this is at negative 3, 0. Does each x have their very own y? No, they're sharing a y, aren't they? So is this one-to-one? It's not. Okay? Is this a function? Because if I do the vertical line test, it passes, correct? And that's what this is telling me. So the vertical line test tells me whether that relation or function is a function. Okay? The horizontal line test, give me 1 second, Jimmy. The horizontal line test tells me whether its inverse is going to be a function. So when I do this, is its inverse going to be a function? No. Because, once again, what is the definition of inverse? This right now is an output, isn't it? And these two represent inputs, correct? But in the definition of inverse, it's the outputs become the inputs, correct? So therefore, here is what the graph would look like of its inverse. Would that be passing as a function? No, because this line represents this black line right here. And it does not, because notice that output became the input. So, what does the vertical line test tell me? If the relation is a function. The horizontal line test tells you if the inverse is going to be a function. Okay? Is everybody there with me? Go back to Jimmy and then over to you.
So the one-to-one, is that how it's done?
A linear equation would be, a cubic would be. Most even powers are not going to be one. A square root would be. So let me explain this. So this is not a one-to-one, because not every x has its very own y. So therefore, if it's not one-to-one, then I know automatically that its inverse isn't a function. Does that make sense? Yes.
Sorry, what do you mean by its own y?
Its own y. You see how x is 0?
Yeah.
3, 0. That's its y value.
So if it doesn't
Negative
have-
3 have its very own y value. No, they're both sharing 0.
Oh, okay.
So like if I drew a graph like this, those guys all share their very own, they don't share at all. Each of them have their very own distinct y value. The inverse of this one, of something that's one-to-one, would have a inverse that is a function. So, did I get to your question, Lisa? I'm sorry.
So, for mine, like, to be like the letter shape C.
Like a sideways parabola?
Yeah. The way that kind of like equations come out, the x equals y equals 1.
No. We're going to do that in just a second. James? Okay, say it again. I'm sorry, James. Yeah, we're going to get to it. The back graph that we just did. You want me to go back there? So this is what the inverse is. Here's my x's, here's my y's. Once again, the outputs become the inputs. So I made this a positive 5. So 5, 0. Negative 4, 1. Negative 2, 2. would be you just switch the x's and the y's. Okay? All right, let's go on to here. So, hello again. Regular function. I got Carolina, so don't worry. So this is plus 8. Where did we start out with plus 8 when we graphed it? At 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then notice we rise 2, run 1, don't we?
Purple against the black's hard to.
Blue, honestly. Down 2, over 1, down 2, over 1. I know I'm a good block. And we cross over here at 4. Okay? Notice y equals 2x plus 8. That would be the graph. That's not the best graph. We'll actually switch that back. I don't care. Okay. That's the graph. Now they ask us to do its inverse. The inverse, once again, what's the definition of inverse? Inputs become the outputs become the inputs. So therefore, the y becomes an x.
Dropping his light. You can't say that, Eric.
I could say shiz. Shiz. You could say that too, Hannah. And I feel comfortable about it.
Say the asymptote word.
You want me to say the asymptote? Okay, I gotta say the Holy chef, check out that asymptote on that mother function. Yeah, I feel comfortable saying that as well. Asymptote. Anyway, thanks for making me almost feel, my job security. I feel safe. Cooper, on the other hand, wouldn't even dare saying that, would you?
Advice of the day.
See? You just send kids, they bring you back some ways. See how that works?
He's like, I'll have to.
I'm trying to teach you to become How many years teacher are you, by the way? It's just part of life. I mark them absent until they come back. Exactly. Okay, so the key thing here, guys, this is called, here was, notice the original was y. This guy's called y's inverse, and how they dictate that is by a negative 1. Okay? Just to give you a heads up. So notice, what did I do? I replaced the x's with y's and the y's with x's. Does everybody see that? And then what did I do? I solved y by itself, correct? Hop in there. Oh, did we get each of our own? Might give them up. Okay, and anyway, I solved for y. So now I'm going to graph its inverse. So I'm going to start at negative 4. 1, 2, 3, 4. And then notice if you recall, I'm going to go up 1, over 2, up 1, over 2, so forth. So it looks like this. Nope, it's not parallel. They will cross. Okay, what an inverse does, though, ladies and gentlemen, it always is reflected over this line. Does anybody know what this line is? The magical line. What is it? Y equals x. All our points are reflected over that. Notice, look at this point right here. What is this point that I told you was? Negative 4 to 0, huh? Look at this point right here. 0, negative 4. They will cross. Because every point has a spot that they equal each other. Because they're not parallel. Because every inverse, especially if they're lines, they'll cross sooner or later at the same point. Does that make sense what I'm saying? Because every line has a value where the x and the y are the same. Does that make sense? And that's why all three of them will cross there, because obviously this guy is at xy, being the same point. if I reciprocate that or make it its inverse, it's still at that same point as well. Does that make sense? They would always intersect. Okay, so notice, look also here. This is 0, 8. And if I kept doing this, where would I cross over here? 8, 0. I would. Because they're inverse to each other. Does that make sense? Everybody good with here? Notice, really quick, what was the domain of this guy? Negative infinity to infinity. Negative infinity to infinity. What's the domain of this guy? Now right here, this doesn't really make sense, but hold on. Meaning the inputs become the outputs. The outputs become the inputs. Yeah. Can't a big guy dance? Yeah. That'd be white with negative x. Because she wants to see the whole board, and you shush your mouth, Mr. Peach.
Mr. Peach now.
Okay, that was a little weird. Okay. So, really quick, the domain of this guy would be negative infinity to infinity. Range would be 5 to infinity. Do I see a hand up? Somebody have that up? Awesome. Okay, so what I want to do right now, I want to find its inverse. So is this somebody talking to me? Why is the range that? Because it looks like this. It's our basic paired function shifted up 5. You okay? All right, so then f of x is just another value for y, isn't it? So therefore I have x equals y squared plus 5. So right there, that makes us the parabola. Like this. But I don't like to have things solved for x. I like to have things solved for y, correct? So therefore I subtract the 5. And then what? Then I square root it. And that's how this becomes, because notice this top part here is the plus square root of x minus 5. This part down here is the negative square root of x minus 5. We're actually going to graph square roots next time on Tuesday. So we'll get in more depth of those. Should I call him the nickname?
No.
Let's make sure you guys flirt a lot. I just saw that twinkle in her eye as she did that.
Yeah, you know
Are you
it.
blushing? I thought you turned naturally brown. So you have a little darker complexion. Baby pink, that's what I do. Right up top of there. Okay, so what is the domain of this guy? Have I not yet? Domain. What number can I not be in here? 5 to infinity. I can be anywhere from 5 to infinity. Because I can be 5. What's 5 minus 5? 0 squared to 0 is okay, right? And notice here's our picture of it. How low does this graph go? Negative infinity to infinity. So notice, ladies and gentlemen, the inputs became the outputs. The outputs became the inputs. Okay, but there's a problem here. Could, but here's the part I'm going to teach you that's a little bit different. Okay, is this guy, so this once again, we don't call him y, what should we call him? Sorry, we should call him f's inverse. Because that was what it is, right? It started out with f of x, so I'm calling it f's inverse of x, because that's the way it should be. Sorry about that. Is everybody okay with that, though? Now, with that being said, Was f of x a function? Yes. Is its inverse a function? Why? It's not one-to-one, right? And I want because this now is not a function anymore, this is a relation. Because if it's not passing the definition of function, it can't be called a function, right? So I always want my inverse to still be a function. So what do I need to do? I need to restrict my domain. Okay, so can somebody tell me, looking here, where does it stop being one-to-one? Where should I start at to stop being one-to-one, where it actually starts being one-to-one? If I start here at 0, 5, right, or x being 0, and I cover this side, am I one-to-one? I am I not? So what I need to do is just say here, but x has to be greater or equal to 5. Not 5, excuse me. 0. Does that make sense? Now I restricted my domain, so the only part I have is this part of the graph. Is that now one-to-one? Is its inverse going to be a function now? And what that part is this part right here. That red corresponds with the brown part. Okay? So what would be my new domain if I restricted it? 0 to infinity, right? So what becomes my new range down here? Because now I'm not using the negative part, I'm just using the top half. So what is my new range? 0 to infinity. But now, my function, or my original relation is a function, and is its inverse. Does that make sense? I had to restrict it. I had to stop it. Now, does it have to be x is greater than or equal 0? Is that the only part? Could I have used this purple part here? Could I have said things that are negative infinity to 0? Yeah, I could do that. But if that was the case, I would no longer have the plus, I'd have the minus. And notice that would be this bottom part here, which is in this orange. And notice what's my range of this guy? Negative infinity up to 0. See how it'll still correspond? The way that you make it correspond with your domain by restricting your domain. Okay, so this is how it's going to ask you. It's going to somewhat on your homework say, is your relationship a function? You're going to say yes, no, whatever. Is your relationship one-to-one? Then you're going to say yes, no, whatever, right? And then if it's not, they might say restrict your domain to make it one-to-one. Does that make sense what I just did and how that's going to be instructed on your homework? Yes, sir. Ken. No, ma'am. As soon as I restrict it, it's just that. Okay? Now, if it doesn't tell me to restrict it, it just says, what's the domain of my function? It's negative infinity to infinity. Right? But is it a function? No. Well, yes, that one is, but it's inverse. Right? Does that make sense what restricting the domain does? So you have to know, is it one-to-one? If it is one-to-one, do I even have to worry about restricting my domain? No, because that means its inverse will be a function. But if it is not one-to-one, they might ask you to restrict that domain to then say what it's going to be. Okay? Make sense? We might even look at a story problem. Like a problem. We got 50. That would be garbage. Okay, really quickly, we might want to do 2 of these ones too. Because those are pretty in-depth. Okay, really quick, find its inverse. So here's f, so I'm going to switch it. Anybody want to help me out there? Square up. Now what? Subtract the thing. So f's inverse of x is x squared. So, but something that you want to talk about, okay? Because I switched the x's and the y's. F of x is another word for y. It's just an output.
Oh, okay.
Are you okay with that?
Yeah.
Because I'd rather put that in than an f of x. Okay? Now, what's the domain here? Negative 6 to infinity, right? The range is 0 to infinity. what is my domain here? Previously, it could have been negative infinity to infinity. But I got to use the range of the domain, range of the regular function, so therefore the domain is 0 to infinity. Because I only care about that part of the graph. Because this dictates what this is going to be. Certainly. And the range is going to be, notice, negative 60. Go ahead. And notice it just flip-flopped, didn't it? Because the original function was 1 to 1. My original function looks like this. Is that a 1 to 1 graph? It is. Does that make sense? If it's 1 to 1, you can just flip it. Okay, really quick here. What's the domain of this? What value can I not use? 5. So domain, negative infinity to 5, union 5 to infinity, correct? Range. Think about the horizontal asymptote. Where would that be? Where would the horizontal asymptote be? Just last chapter. 1, right? How do we find horizontals? We do long division. How many times can x go into x? Once. So therefore we would approach 1, and sometimes don't we approach 1 and actually sometimes don't we cross the horizontals? We can, but in this graph it doesn't. Because notice this graph is. And it's 1 to 1, huh? Okay. It is. So it'd be, nope, the inverse. It's a whole different ballgame. It's not just flipping. Because remember, it's flipping about that axis. Right? Okay, so let's show you how to do this. I'm even going to scroll down because this is going to take some work. G of x equals what again? X plus. Okay, so once again, what do? We switch the x's and the y's, right? Okay, make sure you guys are off your phones for me. I'm seeing a few of you on today. I know sometimes it's kidding me. I don't want to do that. This guy. So how can I solve for y when I got 2 y's? Can I just divide them out? Then I can't solve for y because there's no y. Right? That doesn't even work. Multiply! I love you! Okay? Sorry if you're okay with that.
Sorry if you're okay with that.
Well, she got a little nervous. That's all right. I don't try to make things awkward, just something. Especially if you blush. Then I distribute. And then yesterday I said, somebody said, Mr. Roberts, you just subtract out 3. I'm like, okay. I solved for y. Why?
Is there still another one?
How can you have a solve for y with y in your answer?
Divide?
No, I can't. So, here's what you do. Don't give up! Don't give up! And I'm going to tell you, this is on your test right now. It is. Okay? So, double, wink, wink, hint, hint, study this shit. Okay? What you want to do is everything with a y on one side. So therefore I'm at negative 5x minus 3 equals y minus xy. What do those guys share? How can I make 2 y's go into 1 y? I pull out a y. Way to go, Miss Olsen. Pull out a y. I'm left with 1 minus x. And that equals negative 5x minus 3. Then what? Divide. So there, I'd start out as g, didn't it? So G's inverse of x is negative 5x minus 3 over 1 minus x. So, what I'd like you to quickly tell me, I know I might have went fast there and I apologize, but we're running out of time because we had conversation and Cooper came in, we all know. Okay. What value can x not be? 1. So notice domain is negative, no, it's 1. 1 minus 1. 1 would make that 0 in my denominator, wouldn't it? Negative infinity to 1, union 1 to infinity. Did the outputs become the inputs? And that's a good way to check to make sure you did this right, because it should, shouldn't it? Okay, but let's look at the new range. So how do we find the range? Once again, that comes from long division. How many times can negative x go into negative 5x? 5 times. So therefore negative infinity to 5, union that 5 to infinity. And isn't that exactly what we had previously, just flip-flop, which is the definition of the inverses? You could. If we just cared about inverses of the domain range of the inverse, as long as the graph was what? 1 to 1, right? But obviously, I think in the thing they're going to ask you for this. Okay?
So what do you just tell the bottom of get rid of the line?
Oh, you threw out some shit. So you're talking about right here?
Yeah, right there.
So I just multiplied him over, distributed it through, got everything with a y on one side. Doesn't matter what side. Because if I did it the other way, it would have came out like this. 5x, was it a minus 3 already? So we're going to plus 3 over x minus 1. That's the exact same thing. Okay, you guys. Okay, I gotta do one thing and then we can come back to this. Right? All right. So let me just start here. Here's g of x. It was equal to 4 over x plus 2. I'd like us to hurry and find its inverse, exactly. So we're going to swip swap it. I'm sorry I'm boring. I'm not trying to be boring. Apologize. It's my subject's fault, not my fault. So how do I get y by itself? Can I just subtract the 4 over? No. So I'm going to y plus 2 this guy both sides. So I get xy plus 2x equals 4. I would minus 2x. And then divide by x. So I think that was a g again, wasn't it? Yeah.
So how do you get rid of the x?
This guy right here. I just divided it over. Because in that time, it says x times y, right? The different part of this one is that this guy down here, this is a binomial on my bottom and top, whereas the other one was a monomial over a binomial. So here, I got this guy over here, and these guys over here, or vice versa, whatever, this guy over here. You see where I'm at? Okay. All right. So now it's asking us to check the key thing here. Remember how I started off with this problem right here, how they both came, f of g and g of f both came out to be x? And how I told you those guys are inverses. Think about it. If they're inverses of each other, don't they get rid of all the operations? Doesn't a square get rid of a square root? A plus get rid of a minus. A times get rid of a divide, right? They get rid of each other. Same thing here. If I do g of g's inverse, and it equals x, and I do g inverse of g of x, and I also get x, that proves these guys are inverses of each other. So on the test, what could it look like? I could say, here's g of x, here's f of x. Tell me whether these guys are inverses. And if you actually went ahead and solved them, I wouldn't give you any points. Okay, I want you to do the composition. That's why I taught compositions, because that tells us whether they are inverses. So let me show you what I mean by this. Okay, so g of x was what again? 4 over x plus 2, right? And what was, and then the other one was g's inverse of x, which was negative 2 over x. Okay, if these are inverses, I should be able to do the composition. Okay, meaning g of g's inverse, so I'm just going to plug him in, starting here. Make sense there? Are you with me on that? Okay, which is equal to, I'm going to replace that here, correct? Replacing that. So notice I have 4 over negative 2x plus 4 over x plus 2. What does the bottoms want to do? Well, how are we going to merge them? Common denominator. So I'm going to put an x down here, but if I put an x down there, I'm going to put an x right there. Is everybody good there? So now I'm at 4 over negative 2x plus 4 plus 2x over x. It's actually pretty nice. That's what happened. Now, this becomes 4 over 4 over x. And remember, when I have 4, like maybe divided by 4 over x, what do? You multiply the top by the bottom's reciprocal. I will. That proves, but notice, just going one way does not prove it's an inverse. What else do you need to show? I just did g of g's inverse, right? What's the other way I'd have to go? I'd have to go g's inverse of g. And they both have to equal x. The problem is it works one way, but sometimes it won't work the back way, like a square root. Because what's the square root of, what's x squared? What's the square root of x squared? If I personally take the square root, it's plus or minus x, right? Does that make sense what I'm saying? So therefore, is that exactly x? No, that's plus or minus x. You see what I'm trying to say by that? So that involves something that they're not. It looks like they're inverses, but they're not. Okay? Since we're out of time, I'm just going to show you guys the other way really quick. If you want to be done taking notes, that's awesome. I'm going to do it because I have classroom time. Somebody here, you tell me what is g of x again? Okay, and then this was, you said 2x. Plus 4, you said, over x. Okay, so what I would do here, I know you guys are still done, but you can just listen for a minute. So what I'd do here is I'd distribute that through, so I'd get negative 8 over x plus 2, but I'd hurry and get an x plus 2 here. Do the common denominator, and that would become plus 8, 4x plus 8, notice those guys cancel, over, oh my hell, sorry, I gotta quit hitting that button. You guys enjoy. Have a great weekend. I'm going to finish this if you want to stick around. Over 4 over x plus 2. Nobody's listening, I'm going to stop. Can I just finish and then I'll come back to you? Then notice I'm going to flip him.
Anyone who's riding the Steeler bus, that bus will not show up today. You need to ride the BMW bus if you would like to get home.
Doing G of F, it's kind of like doing the G of F and F of G. You got to do both ways.
And then, so you do both ways on the test? Otherwise, like you only do one way, but it don't work.
I'd only give you half. Does that make sense? Maybe stroke a little bit. I know that was kind of messy right there.